Example of using synthetic division and the intermediate value theorem to find just the possible location of our root. And then we can, become a computer and figure out the rest of it. So let's start off with just synthetically dividing this function f of x on this interval from x equals -2 to x equals 2. And we're just going to use integers to climb up these values. So we're going to synthetically divide into this, so let's write it out. We're dealing with 1, 2, 3, and 1 as the lead coefficients there. And we're going to synthetically divide in starting with -2 and just kind of go in order to these values. So let's see, drop a 1, that'll be -2, that'll give you 0, that'll give you 0 plus 3. This will give you -6 plus 1, which will give you a -5. Alright. And then -1, drop a 1, that'll give you a 1, that'll give you a 2, that'll give you a -1. So far, nothing interesting happening. Alright, so let's try 0. Drop the 1, 1 times 0 is 0, 0 plus 2 is 2, 0 again, plus 3 is 3, 0 again, plus 1 is 1. Alright, and then just kind of keep on going. 1, drop the 1, and you get 1, which is 3, you get 3, which is 6, you get 6, add to the 1 is 7, and 2. Drop the 1, 2, 4, 8, 11, 22, 23. Now there's a couple interesting things going on here. As we go down these values, these numbers seem to be getting bigger. And also, if you look at it, each one of these rows is a all positive number. So what we're going to say is, when they're all positive, every single answer, we're going to call x equals 0 here an upper bound. The second interesting thing that happened here is between this calculation and this calculation, the sign changed on our answers from a -1 to a positive 1 in this case. That means there must be a solution somewhere between -1 and 0. So a root or a 0 exists between x equals -1, oops, and x equals 0. Now we could, estimate maybe like -0.5, go through the synthetic division, see if the answer is positive and negative, and kind of get it closer to one of these two values. I wanted to do one more line. I'm curious if it'll work. Let's do backwards, -3. So drop down a 1. That'll give you -3, which will give you -1. This will give you a +3, which will give you +6. This will give you -18, plus 1 will give us a -17. This line is also kind of important. Notice what's happening. We're going from positive to negative to positive to negative. So what we're going to say with alternating signs is here x equals -3 is called a lower bound. We're not going to find any answers smaller than -3, any roots smaller than -3, and we're not going to find any roots higher than x equals 0. So this kind of gives us an idea that we can squeeze all our work between x equals 0 and x equals -3. And that comes in handy when we're really looking for specific roots.